Find the radius of convergence for that function. That looks tricky. We're going to do the ratio test. So the ratio test says that the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, when it's less than 1, the series converges, right? You can add them up forever and it's still a finite sum, as long as the next term over the previous term, the ratio is less than 1, meaning the next term is lower than the previous term. Terms are getting lower, they'll add up to something finite. You add them up forever, they'll add up to something finite. Series will converge when that's ratio is less than 1. Okay, so that's the game plan. Let's do it. Limit n goes to infinity. All right, a sub n plus 1. So I'm going to go n plus 1 factorial, plugging in n plus 1 right there. Um, Cubed. It's getting messy already. Over 3n plus 1 factorial x to the n plus 1. What a mess. Over, that's all a sub n plus 1. Now on the bottom, a sub n, which would be n factorial cubed over 3n factorial x to the n. But look, let's just flip it up, right? Dividing is upside down, multiplying. So I'll just do that. I'm just going to flip it up. And so we're going to get, what are we going to get? 3n factorial. Oh, so it's upside down, right? We flipped it up, n factorial to the third. This x to the n was really over 1, so now it's on the bottom, x to the n. Wait a minute. Oh, and this guy was on the top. What am I doing? I'm getting all monkeyed up, right? Because this is over 1. This should be x to the n plus 1 like that. All right. Absolute value, this less than 1 is where it converges. Okay. Got to clean this up. This is messy. So how are we going to do this? Well, I'm going to do this right here. This is 3n plus 3 factorial, right? So then I'm going to go, okay. Let me move this down just a little bit. Okay, so yeah, what am I going to do here? Is n plus 1 factorial? What does that mean? So you know what a factorial means, right? Like 7 factorial. That means 7 times 6 times 5 all the way. In other words, it's 7 times 6 factorial, isn't it? You can peel off the first number and then it's 6 on down. Well, I'm going to do that with the n here. I'm going to go look, that's n plus 1 times n factorial, all cubed, right? This is this. I just rewrote n plus 1 factorial as n plus 1 times n factorial cubed. Okay. Then we have x to the n, x to the 1, right? Because you add powers over 3n plus 3 factorial. Well, I'm going to do the same thing there. I'm going to go look, that's 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial. Does that make sense? Because 3, you just keep going down. Right, again, if I could take 7 factorial and say, look, that's 7 times 6 times 5 times 4 factorial. Anytime you want, you can do a few and then hit factorial the rest of the way. That's what I did. I did 3n plus 3. It goes down by 1 every time, then factorial the rest of the way. Why? Because I want to cancel it with that other 3n factorial. See what I'm doing there? I'm getting it all set up to do a nice thing. 3n factorial. This is n factorial cubed, x to the n, absolute value, want it less than 1. All right, can you see what's going to happen now? Some nice things will happen now. Okay, so let's cancel. So we got 3n factorial, 3n factorial. And, oh, I'm going to do this third power. I'm going to put it on each one. It's on this guy separately and this guy separately, right? It's third power on the whole thing. Right, it was third power at n plus 1 factorial. That's n plus 1 times n factorial. Third power on both, right? Third power on everything in there. So then I can cancel. What can I cancel? Um, I thought something really wonderful was going to happen then. Oh yeah, this will cancel that, right? They're gone. All right. No, and this cancels that. All right. So what is left? X on the top right there. Kind of circle things, cross them out. Okay, what on the top I have n plus 1 cubed. On the bottom I have 3n plus 3. Oop, here, that's getting ugly. Let me Be a little more careful. So n plus 1 cubed on the top. I'll circle that. And then on the bottom, 3n plus 3, 3n plus 2, 3n plus 1. Right, circle, circle, circle. If I got everything, yeah. See how I cross out everything, circle everything? So I make sure, so many terms. I'll make sure I didn't. Everything's either crossed off or circled. All right, absolute value of it, less than 1. So what does that mean then? Limit n goes to infinity. Now, what's going to happen here? We have x, so this big old fraction bar. We have x. Actually, let me separate them like this. It's just x over 1 times, and I'm going to write it n plus 1 cubed. And you know what? What is n plus 1 cubed going to mean? It's going to mean n plus 1 times n plus 1 times n plus 1 over 3n plus 3, 3n plus 2, 3n plus 1, right? Absolute value less than 1. Now, we're going to infinity, right? N's going to infinity. So I'm going to plug in infinity, 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 and all those n spots, right? What matters when you have a fraction and you're going to infinity? Only the most powerful term on the top and the bottom. Remember that from limit stuff we've done before? So this is x over 1 times. So really, I'm just going to multiply together the most powerful term on the top. That's n cubed plus smaller in stuff, in powers, right? Over what's on the bottom. 3n times 3n times 3n, 27n cubed plus smaller in powers. I don't really care about the smaller stuff. It's going to go bye-bye, right? You tracking with me? I'm just saying if I foiled out this whole top, there'd be a bunch of work. I don't want to do it. But I know what the most powerful term is. Most powerful here, most powerful here, most powerful there, n cubed. Same thing on the bottom. Most powerful, most powerful, most powerful. 27 n cubed, right? 3 times 3 is 9 times 3 is 27 n cubed. So, and then there'd be some smaller n stuff, smaller stuff. Well, when you go into infinity, all you care about is the most powerful term, top and bottom. So all I care about is these guys. So the n cubes cancel. It's 1 over 27. So it's absolute value of x over 1 times 1 over 27 less than 1. The limit's done. And notice I'm not writing the limit out here. Why? Because I did the limit. I just did infinity and infinity, and they canceled. Because it's same power, same power. And the smaller stuff is for sure gone. Only the most powerful term matters when you're going to infinity, right? If you have an n cubed and then an n squared, plug in, you can plug just 100. 100 cubed compared to 100 squared is 100 times bigger. He's so much bigger, this guy doesn't even matter. We're only at 100. Go to a million, a billion, a trillion for sure. Only the most powerful term matters. Most powerful, that's why all I care about is the most powerful term on the top and the bottom. Cancel them out. We're left with 127. Solve for x. Multiply both sides by 27. Boom. Absolute value x less than 27. That's it. That's a radius of convergence. And that is the answer they had up here. So a little bit of simplification. And so there we go.